Hello everyone, and welcome back to another cartography lecture video. And in this video I want to continue our discussion talking about scale and generalization by really focusing in on this concept of scale. In the introductory video I said that there were sort of two terms that we needed to be aware of when talking about scale. One being geographic scale and the other being cartographic scale or map scale. And then there's a third term that I want to introduce in this video called data resolution, and I'm just going to write it over here to keep track of it for later. And what I want to do is I want to talk about these two different types of scale, cartographic scale and geographic scale, in sort of a way that highlights the role they both play in cartography, but also in a way that highlights their differences in the perspective that they use when talking about this idea of scale. So in the last video, we said that geographic scale was this sort of idea that scale was talking about extent of the map, or the sort of size of the region being mapped. And so you can think of this as, again, just for the notes here, geographic scale sort of describes extent. Or you can also think of it as describing the size of the units being mapped. Right, and so for geographic scale, you might hear something like someone might say, yeah, we're going to be mapping at the county level. Or you might hear somebody say we're mapping something at the global scale. I'm using level here, but in this particular case, level and scale, I'm using those terms interchangeably. So you could have the county scale, the global scale, the state scale, right? All these different sort of geographic terms here are being applied to geographic scale to describe the extent of the region being mapped. So if I were to say, hey, we're making a map at the global scale or global level, right, that means our map is going to show the entire globe. Right, if I say something is being mapped at the county level, right, that means that our map is going to show one or more counties. Right, and you can already see I sort of picked two extreme examples here. But the difference in sort of scope between something that's showing one or two, maybe three counties and the detail that would be involved there versus a map that's showing the entire globe and the sort of lack of detail that would be involved there. So that's this idea of geographic scale, right? It describes the extent of what's being mapped, and this is usually done by describing the objects, the geographic units that are being mapped specifically. So that's geographic scale. Right, the other type of scale we talked about was this idea of map scale or cartographic scale. Cartographic scale, or sometimes you'll see this called map scale. Right, and we've already kind of talked about this a little bit in previous videos, but cartographic scale or map scale is this mathematical relationship between the size of an object on the map and the size of the object in the world. So again, to reiterate, this is the size relationship between objects on the map and objects in the real world. Right? And so you've probably seen, when you think about scale in cartography, you probably think about map scale because you've seen something like a scale bar. Right? A scale bar is a visual representation of this idea of map scale. And we talked about map scale when we talked about projections. So when we talk about cartographic scale or map scale, you'll typically hear someone talk about this idea of the representative fraction. Or RF. Right? So the representative fraction, this is based on that principal scale that we talked about in terms of that reference globe with projections. Right? That's being brought back in here when we talk about the map scale and this idea of the representative fraction. So a representative fraction, just as a review, consists of two numbers. Typically, the first number is going to be a 1. That's sort of a very common, practical way of setting this up. I'm going to do this. And then you have a colon, or sometimes it'll be a vertical bar, but usually it's a colon. And then you'll have some other number, say, let's just say 1,000 for ease of use here. And so what will happen with the representative fraction is that we have the two numbers and the colon. And so this would be written in English as 1 unit on the map represents, oops, that got really sloppy, give me 1 second, that represents 1,000 units in the real world. Right, and so we can think, taking this sort of English here, 1 unit, so this 1 unit here, 1 unit on the map, right, this is being pulled from this 1 right here. That's what this represents. This is how many units on the map. So this is going to be map units. Represents, right, that's coming from this colon here. So this is the represents. Right, represents. And then this 1,000 units in the real world, right, that's this number coming from this number right here. So this is real world units. Right, so again, map units represents real world units. So you can think of this as a representative fraction because it's representative, saying what 1 unit represents in real world units. And it's a fraction because you can think of this as a fraction, 1 over 1,000. Okay, so hopefully that makes sense. So again, right, 1 unit on the map represents 1,000 units in the real world. And there's one key point. There's one key point that I want to make about this idea of a representative fraction. And that's that it is a unitless number, right? It is a unitless number. That's why when I wrote this in English down here, I said units. Right? I didn't say miles, kilometers, or centimeters, because this fraction right here can be used for any unit we want. If our map was big enough that we could measure feet, if we could put a ruler on the map and measure something in feet, right? 1 foot on the map would represent 1,000 feet in the real world. Typically, maps aren't that big, so you're typically dealing with inches and centimeters. But again, right, it doesn't matter, right? This is a unitless number. We can put any unit we want as long as the units are the same on one side and the other, right? We could do 1 foot, 1,000 feet. We could do 1 inch, 1,000 inches. We could do 1 mile, 1,000 miles, right? As long as the units are the same, we can pick any unit we want. So hopefully that makes sense. I'm actually going to stop this video here, and in the next video I want to talk about data resolution and this idea of large scale versus small scale. So as always, if you have any questions, please reach out. Thank you.